Hello students, so let's try to solve one more problem, and it is from IIT JAM 2021, and this is NAT type problem, numerical answer type, and this problem belongs to mechanics and collision and conservation of energy as well as conservation of momentum. So problem is very straightforward. There is a mass m, and that is A is the particle whose mass m, and there is particle B whose mass is 2m. A will A have velocity with in I cap direction and it collide with B, and after the collision A will move in J cap direction exactly perpendicular to that direction with speed VA, and B will move with speed VB. So we have to calculate what is the relationship between VA square and VB square. So VA square is equal to, let's say, K time VB square. So we have to calculate the value of K. So it's a quite simple problem. Hence, it is moving in Y cap direction. So for the conservation of momentum, we can assume that B is making some angle theta after the collision, and it has speed VB. So what we can do, we can resolve this VB into two part. So this will be VB cos theta, because I am taking this theta with x-axis, and this is my line of action, and this is basically VB sin theta. So what I have to do, I have to just go for conservation of momentum as well as conservation of kinetic energy, because the collision is elastic in nature. So let's try to write conservation of momentum in x direction. So in x direction, I am writing conservation of momentum, that is m into v plus 0, because it is at rest, and after then we have 2m vb cos theta. This is for x direction. For y direction, we have m into va must be equal to, or you can write something that 0, there is not any momentum in y direction, so this will be 0 is equal to m into va minus 2m vb cos theta. So this is conservation of momentum in y direction, and then we can go for conservation of kinetic energy. So when we are going for conservation of kinetic energy, so that will be half m v square is given plus 0, because it is rest, and then we can go for half m va square plus half 2m vb square. So now we have to solve these two things such that we can find the relationship between va square and vb square. This is the actual challenge, and about up to this thing, everyone can be solve in a very easy manner. Everyone can write this equation, but look at how we are going to solve it. So what we will do, we will take into this side, and we will make the perfect, we will take the square and add it. So what we will get, so we will get m will be cancel out, so we will get basically v square plus va square is equal to 4 times vb square. So this is my equation 1, and second equation is also given in term of square, because we have to write each and everything in term of va square and vb square. So half m, and again half m is gone there, so we have v square is equal to va square plus 2 times vb square. So when we are going to solve this equation, and then we can easily have something, we have to remove this particular v square. So I can write this thing as v square minus va square is equal to 2 times vb square. So what we are going to do, we are just taking this first equation and this is my, let's say, third equation. So I am taking this one and we are just going to subtract this thing such that this v square can be cancel out. So this is negative, this is positive, this is negative. So we have 2 times va square is equal to 4 minus 2 is again 2. So this is 2 times vb square. So this 2 will cancel out. So we have va square is equal to vb square. So k is equal to 1. So obviously in this problem, we have to put k is equal to 1. So obviously it's a quite simple problem, just +2 level problem, but in the examination pressure, how you are going to calculate all this stuff, this is very important. So you have to cool yourself and you have to see what is the notion of final answer, and onto that basis you have to calculate each and everything. Thank you.